everybody's muted. Hello? Hello? Perfect. Okay, great. Let's get it. 17 questions on this final. It's been a pleasure, everybody. First question is going to roll about finding the inverse. Um, Here are the steps that we had. Let me make my, and let me go ahead and double check, make sure that everybody is muted here. I got one person who's not. Okay, perfect. All right, so I've got f of x equal to 3x plus 4. Again, because, um, thank you. F of x equals 3x plus 4 over 5. We're trying to find the inverse. Here are the steps. And again, we're not doing this in the active way. We're not sitting back right now just being like, oh, ho hum. We're trying to get ready for the final, right? So let's be dialed in, writing these notes down, because the 17 you see now are going to be the 17 on the way right now. So we said y equal to 3x plus 4 over 5. We're going to switch the x's and y's. Of course, they want to start working on my lawn right as I start doing this. X equals 3y plus 4 over 5. We'll switch the x's and y's, and now we want to solve for y. Right, so we'll multiply both sides by 5. So then 5x equals 3y plus 4. We'll subtract 4 on both sides. 3y equals 5x minus 4. Divide both sides by 3. That is straight up the inverse D. Again, you'll have access to these notes in D2L with the link. And so there, this ID, you can practice this problem all as much as you like by going to the study plan, going to chapter 2, section 7, problem number 6. Number 2 has to deal with an exponential function. We talked about exponential functions a little bit. Page for this. We got a function A, which models the amount of pounds of a particular radioactive material stored in a concrete vault, where X is the number of years since the material was put into the vault. The 800 pounds to start, which means that this thing right here is 800. This is the starting amount. How much time will need to pass for only 343 pounds to remain? So you're looking for this. So now we're experts at this. Remember, I was trying to buy my Toyota Camry. So we're looking for this time, right? And this is 343. And we're just going to solve that equation. 343 is equal to 800 times e to the negative 0.00770x. We're solving for x. I'm going to try to get x by itself. I'm currently multiplying by 800. I need to divide both sides by 800. So I'll divide here, divide here. The only thing we need to be careful about here is going to be rounding. That equals e to the negative 0.0077x. And of course, now we know that if we're solving an equation like this and the unknowns in the exponent, then we need to apply the natural log. So the natural log of 343 over 800 equals ln of e to the negative 0.0077x. And we know that this is going to stay the same. And again, the natural log and the exponential, they cancel, and this is negative 0.0077x. Of course, I'm solving for x, obsessed with getting x by itself. I want to divide both sides by everything that is not x. And then we are x equals ln 343 over 800 all over negative 0.0077. And again, at this point, no need to try and be a hero. Use something other than the best calculator out there. Throw that in the Desmos. It'll give you the nice number. Again, I'm rolling with y'all, making this multiple choice. ln of 343. And again, if you don't get anything that looks like one of the choices, then we're talking about perhaps we missed the minus sign, or perhaps we just enter it in wrong. What's great about Desmos is that it looks nearly identical to how you would write it on paper. 109.984 years. We're looking for an answer choice that is 110 years. A. So the idea remains the same, that assign correctly, divide by 800, solving for x in the exponential, apply logs to both sides, and divide. Number 3, evaluate the function at the given value of the independent variable and simplify. Of course, the crucial element here is to simplify. So all we're going to do is we're going to have x squared minus 2, and instead of this x, we're going to put in x minus 2. And so f of x minus 2 is equal to x minus 2 squared minus 2. Now they're going to want us to square the x minus 2, subtract 2, and that will either be a, b, c, or d. We'll recall that when we square something, you end up multiplying it times itself. So we'll FOIL out, and then we'll be good. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x, and negative 2 times negative 2 is positive 4. Don't forget this negative 2 here, because the answer choice here is the one if you do forget the negative 2. That's how vicious they're being. X squared minus 4x. 4 minus 2 plus 2. The answer is A, not C. If you want to practice this, study plan, chapter 2, section 1, problem number 23. Where there's an x, you put in x minus 2 and square everything and simplify. Use the given conditions to write an equation of line in point slope form. Y minus y1 equals m times x minus x1. Here they've tried to hide 2 points. The point here is 3, negative 2. They're telling us that the x-intercept is negative 3. That means the other point is negative 3, 0. We know that to find the line, we need a point and a slope, point and a slope, point and a slope. The point is, I'll pick negative 3, 0. Let's do that. X1 equals negative 3. Y1 equals 0. I've chosen that. You could have chosen the other one. All right, and now we need to find what m is. We'll use the m equals y2 minus y1 over x2 minus x1. All right, so that's going to be 0 minus negative 2 all over negative 3 minus 3. Positive 2 over negative 6, negative 1/3. That's the slope. All right, so it looks like they want to use a different point, so let's use the point they have. So then it's y minus negative 2 equals negative 1/3 times x minus 3. Y plus 2 equals negative 1/3 times x minus 3. Y plus 2 equals negative 1/3 times x minus 3. Right, so that means it's not this one. It's not this one. All right, so that means now when we solve, so it's either B or C, and now we just need to solve a little bit more. Or we can use the other point, right? So if we use, so this one comes from using the point that was given, and let's see what the other one does. If I use this one instead, if I use this point, then you're going to get y minus 0 equals negative 1/3 times x plus 3. Y equals negative 1/3 x plus 3. And that is this one, C. Let's circle these. So we're talking about this one or this one, just depending upon which point you use. Either way, you're going to get C. Number 5, we're talking about solving a quadratic equation. So again, multiple choice, so there's some possibilities there, but we'll subtract 9 over 4x squared minus 35x minus 9 is equal to 0. And here you do have the option of going ahead and plugging in answer choices to see which ones are right. You could graph this function, see where it crosses the x-axis, or we can factor. I need to get a negative 35 in the middle, 4x, x, negative 9, positive 1. Right, so again, you can play around with all the factors. Let's look at all of these. Right, so I could have done 2x minus 9, 2x plus 1. You can try all these possibilities, but then you'll see that the only one that works is this one. Because when you FOIL out, you have to get a minus 35 in the middle. That was that whole factoring we did earlier in the semester, right? Again, we can take advantage of the fact that this is multiple choice by just looking at the answer choices and seeing that the answer has to be one with a 9 in it, and then the other one can't be negative 4. But let's go ahead and finish this. This means that 4x plus 1 is equal to 0, or x minus 9 is equal to 0, in which case x is 9, or 4x is equal to negative 1, or x is negative 1/4, in which case the answer is B. Again, you can just plug in those as well or do the factoring. Here, graphing problem, begin by graphing 3 to the x, then use the transformation of this graph to graph the function. Be sure to graph and give the equation of the asymptote. So the thing you want to do is you'll click on the My Math Lab button, graphing tool, to graph, right? And so it's going to tell you, so our job here is to give it the asymptote, and you're going to have to draw a horizontal line. And so the current asymptote of 3 to the x is y equals 0, and this is a shift down by 1. So the equation for the asymptote, if I'm shifting everything down by 1, then it shifts down to y equals negative 1. It shifts everything down 1 unit. The domain remains minus infinity to infinity. The range is going to be negative 1 to infinity. And again, you might want to take the time to graph that in Desmos. Again, 3 to the x is here, 3 to the x power. And then when you do 3 to the x minus 1, 3 to the x, all minus 1, it shifts everything down 1 unit. So we know that the domain, I'm sorry, we know that the range of, well, first of all, we do know that the domain is minus infinity to infinity. But then the range of the original one was 0 to infinity. But again, if you shift everything down 1 unit, then the domain, the range goes down 1 unit as well. And so then you'll plot the line y equals -1, the dotted line, and then you'll shift the exponential down 1 unit. Solve the following logarithmic equation. We finished talking about logs recently. I've got log base 2 of x plus 2 equal to 2. We know how to roll with this. Using the definition, this means that 2 to the second power is equal to x plus 2. 2 to the second power equals x plus 2. And we're off to the races. 4 equals x plus 2. Subtract 2 on both sides. X equals 2. 2. Right? So what they want here is that they want 2 to the second equals x plus 2. Just do not solve for x. They might take 4 as well. So you can either write 2 to the second equals x plus 2 or just 4 equals x plus 2. And then they want you to solve for it.
I have a question. If we put something in wrong, is there any way that we could email you, or is it
That's a great
totally
question. So there are two things there. So the hope is that you do the practice exam enough times so that you find out all the ways they want you to enter it in. And then the second thing is that um, just depending upon how early you submit, because this thing's due the 22nd at midnight, and at 12:01, I'm going in and I'm checking everything, and I'm putting grades in, and so I mean your chances of me correcting something and giving credit for something that's small are much higher the earlier you do it, but you don't want to do it too early that you're not ready to take it either. And but
right?
the hope is that you practice enough that you see all that stuff and not have to rely on me being a nice guy to give you credit for it.
Okay,
Yep.
gotcha,
But otherwise, I probably will. But if it's too close to when I have to turn in grades, I probably just won't be able to get to it.
gotcha.
Yep.
Thank you.
Always. Vertex. I'll take this whole one. We'll try to make this a tad smaller. Oh, wait. Let's do this. All right. All right. So we've got x squared plus 2x minus 8. So we know that the vertex occurs at negative b over 2a. So a in this case is 1, b is 2, and c is negative 8. And so what we'll do is we will calculate this. So for us, it's x equals negative b over 2a, which equals negative 2 over 2 times 1. The x coordinate of the vertex is at negative 2 over 2, which is negative 1. We need the vertex as a point, so we need the y coordinate. You find the y coordinate by doing f of negative 1. You plug that into the original function, and it gives you the y coordinate. Negative y squared, negative 1 squared plus 2 times negative 1 minus 8. 1 minus 2 minus 8, negative 9. The vertex is -1, -9. That gives us a ton of information. Namely, it tells us the axis of symmetry is x equals -1. And just like my family had asked just a second ago about what happens if you make a silly mistake, this is one of those places where it asks for an equation. You'll do this, get that -1 is the x coordinate. For this one, you need to write x equals -1 because they want a line that's going to split this thing in half. The domain's always minus infinity to infinity. The range in this case is going to be -9 to infinity. It's the y coordinate of the vertex to infinity with a bracket. They'll then ask you to graph it, the vertex. They'll ask for 2 points. They'll want to know the vertex, and then you can use the y-intercept for the other point. And so -1, -9. I do want to double check that. That looks right. -1, -9 is here. They'll ask for the vertex, and then here they will have the y-intercept. So it looks like that. Take any questions there?
I'm kind of
Go ahead.
confused because it's -1, -9. So shouldn't it be over further and instead of
Oh, I'm
un-
sorry. I don't know why that looked like -1 to me. -4. Thank you.
okay, I was
It
so
looks like,
confused.
yes, -1 is here. Thank you. -1, -9, and so it looks like that. Thank you. I looked at that -4. It looked like -1 to me. Yeah, and then the system will do the rest in plotting it. Solve the polynomial inequality. We did some polynomial inequalities. This one is one they want us to put on the test. We'll have to do some factor by grouping. Again, this is one that you can graph as well and see what the result might be. We'll copy it over here. I've got x to the 4, x to the third, plus 4x squared minus x minus 4. And we want to check the signs of that. And so what we'll do is we'll set this thing equal to 0, and we'll do a number line. So we'll factor by grouping. What in the world does that mean? Let's take a look. That means that we'll take x cubed plus 4x squared minus x minus 4, and then we will factor them into groups. We'll notice that the first two terms have x squared in common, leaving an x plus 4. The next two terms both have a minus sign, leaving an x plus 4. We know how to factor this. That means that they both have x plus 4 in common. We'll factor that out, and that leaves us with x squared minus 1. So we can do a bunch of things. I can just set x plus 4 equal to 0. I can set x squared minus 1 equal to 0, in which case I get that x is equal to -4, or x squared is equal to 1, in which case x is equal to 1 or -1. We then create a number line with -4, -1, and 1 for the factored form x plus 4 times x squared minus 1. We're going to pick values and see whether you're positive or negative in each one of these sets. pick x equal to negative 10 here, x equal to negative 3, x equal to 0, and x equal to 10. And we're just checking positive or negative when we plug in to x plus 4 times x squared minus 1. Negative 10 plus 4 times negative 10 squared minus 1 is going to be a negative 6 times a 99 negative. Negative 3 plus 4 times negative 3 squared minus 1 is going to be 1 times 8 positive. When I plug in 0, I get 0 plus 4 times 0 minus 1, 4 times negative 1, negative. 10 plus 4 times 99, 14 times 99, positive. Which one am I looking for? I'm looking for the plus because I wanted to know when this was bigger than 0. We'll make that remark. We're looking for the plus. Positive because it's greater than 0 in the problem. Where's that? I need a positive between negative 4 and negative 1. I need a positive past 1. I need a positive past 1. This is the only one in which that could work. We're halfway there, looking for the 11, 12, 13, or 14 that we need to get the grade that we need. Okay. Use a leading coefficient test to determine the graph's end behavior. We said this before about, we're talking about n and a. If we have ax to the n power, if a is positive, if a is negative, if n is even, and when n is odd, right? And so this thing here looks like this looks like this looks like this, and this looks like this. So then right now the highest power is 1x to the fourth. 1 is positive, 4 is even, and so that means it's going to rise to the left and rise to the right. Rises left, rises right.
Could you explain the part in purple again? I'm just kind of
For
confused.
which one?
Just like the 1x to the fourth, one is
Yeah,
bigger
that's
than.
right. That's right. So thank you for your question. So you're looking for the highest power is x to the fourth, and you care about the number in front of the x to the fourth. Because it's not there, it's a one. And because one is positive and 4 is even, then it's going to have this behavior that it rises to the left and it rises to the right.
Okay, I get it. Thank
Yep.
you.
Yep. The x-intercepts. That means we're going to set this thing equal to 0 and solve. We did this when we were doing higher order equations. X to the fourth minus 9x squared equal to 0. The thing you got to do for these always is to factor. They both have x squared in common. X squared times x squared minus 9 is equal to 0. And now you set, or you can keep factoring if you like. X squared minus 9 is x minus 3 times x plus 3 is equal to 0. In which case, you get x squared is equal to 0, x minus 3 is equal to 0, or an x plus 3 is equal to 0. In which case, you get 0, 3, or negative 3. Now at this point, go ahead and graph this thing. There will be some other questions that we'll be able to take a look at here. So x to the fourth minus 9x squared. And you'll notice that this thing's going to cross in three places, but it crosses or it hits the x-axis in three places. Here, as we said exactly, at 0, -3, and 3. But it touches the x-axis in different ways, right? So the way you hit the x-axis at 0 is different from how it hits at -3 and 3. How? Because it crosses through at -3. It crosses through at +3. But at 0, it just touches and turns back. That's what they're asking about. At which zeros does the graph actually cross through the x-axis? -3 and 3. Cross through. The way that you can tell by just looking at this is by looking at the power of the x minus 3 term and the x plus 3 term. They're both odd. The 0 is the one that turns. At which zeros does the graph of the function touch the x-axis and turn back around to where it came from? From the graph, you can tell that that's x equals 0. Or you can tell because this power is even. Floor is open for questions on that. So you just look at the graph, see which ones cross through, see which ones turn back where it came from. F of 0, plug 0 into the function. F of 0 is going to be 0 to the fourth minus 9 times 0 squared. That is 0. Let's go to the origin. All the powers are even. That makes it an even function. And we already graphed this. We know it's C. This C is the only one where it hits the x-axis 3 times anyway. -3, 0, and -3. A +3. Next two are similar. Write an equation in standard form. That means a times x minus h squared plus k. We're only testing whether we know the formula. I want it to be 5x squared, but I want to move it. I want to move it 4 to the right and 1 up. On the inside, it's the opposite. That's what they want. This one I want to move 2 to the left and 1 down. Straight up using the formula, reading it off. For the x coordinate, changing the sign, leaving the y coordinate the same. Solving for s, first find the restriction of the variable, then solve the equation. So here, we'll get rid of the denominators. First of all, we'll set the denominator equal to 0 and solve. Set the denominator equal to 0 and solve. So we can make sure that we're not going to get anything that is wild, right? So these are all the same, basically. This is x equals 1. This is 3x equals 3. And so x equals 1. I do not want x to be 1. That would make the denominator 0. When we do this one, we get to factor out a little bit. 18 over 3 times x minus 3. You can factor out a 3 in the denominator plus 1/3 equals 6 over x minus 1. And so we've got the 18 and the 3 cancel. So you've got 6 over x minus 1 plus 1/3 equals 6 over x minus 1. And of course, that is impossible. Right? So if we subtract 6 over over x minus 1 from both sides, you get that 1/3 is equal to 0. And that means no solution. And so don't be 1, and the solution set is empty. So that symbol means no solution. Last thing we talked about is systems of equations. Let's see if we can label. The Family Fine Arts Center charges $20 per adult ticket, $13 for every senior citizen ticket for its performance. On a recent weekend evening, there were 456 people, adults and senior citizens. The total receipts were $6,817. How many who paid were senior citizens? Right, so I got two things I have here that I don't know. I need two equations. Here's one. Here, where's the other one? The other one involves some money. $20 for all the adults, $13 for the seniors. Here are your two equations. Eliminate. I'll eliminate. Ooh, well, if I'm looking for the senior citizens, let me eliminate the adults. So I'm going to eliminate A. So here's equation 1 and equation 2. And then I'm going to multiply equation 1 by negative 20. So then that gives me negative 20A minus 20S. And then now I need 456. Let's see if this is rolling right. Oh, I don't know why I'm using that. Where's decimals? 456 times 20. 9120. It's got to be negative. And then we're going to add negative 7s equals 6817 minus 9120. Minus 9120. 2303. I want to make sure I'm putting that in right. 6817 minus 9120. Okay, good. Negative 2303. And then we'll divide. By negative 7. 329. Game. Eliminate. So off the record, this is one where again you label correctly. I like label. You could label it with X and Y. I label with A and S just in case I don't mix up my X's and Y's and actually write the answer for the number of adults instead of the number of students. So that's why I use A and S, so there's no confusion at all. It also lets me know which one I should eliminate, which is A, because they were asking for S. Using log rules, we know that log base 4 of A over B is log base 4 of A minus log base 4 of B. So now we're talking about, and we also know that the square root power, of course, is the 1/2 power. And we all know that log base B, all powers can come out in front. So this is testing all of those rules at once. Log base 4 of 16 over x minus 1 to the 1/2 is equal to log base 4 of 16 minus log base 4 of x minus 1 to the 1/2. Of course, we can bring that 1/2 power in front, and we're almost ready once we realize that we should know what log base 4 of 16 is. It's the power we raise 4 to get 16. That is 2. D. And again, you'll be able to read that off pretty quickly as you get to number 15. Average rate of change between two functions. I've got f of x equals x squared plus 5x. Average rate of change is you plug in x2, subtract the value at x1, and divide by the difference in x2 and x1. So in other words, for this one, it's f of 4 minus f of 2 all over 4 minus 2. We're plugging in. We'll take our time. F of 4 is what you get wherever there's an x, you put 4. 4 squared plus 5 times 4. 16 plus 20, that's 36. F of 2, 2 squared plus 5 times 2. 4 plus 10, 14. And therefore, f of 4 minus f of 2 is 36 minus 14 over 2. 22 over 2, 11. For the game. We need f of g of x. I made this nice for you. We'll just plug g inside of f. We'll see what happens when that happens. It turns out these are inverses. So f of g of x is equal to 3 times all of g minus 7. This is equal to 3 times, well, g is x plus 7 over 3 minus 7. 3's cancel. X plus 7 minus 7, x. F and g are inverses. That's x. Well, if that one's x, this one has to be x. That means whatever number you put in, you're going to get the same number back out. I'll stop the recording.